Okay, this is 9.6 notes. We're talking about the equations of circles. On your cheat sheet, I want you to be very familiar with this portion. Right here I tell you what the equation of a circle is. It's going to be there with you on the test as long as you know how to use this portion. So the standard equation of a circle is written like this. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Notice how h and k are simply the location of the center of the circle. R is the radius. So this equation right here is what you're going to have with you on the test, and I want you to be familiar with how it works. If we're looking at what are the coordinates of the center of this circle, I give you the equation, and I want you to tell me what the answer is, what the center is. We look at the coordinates, okay? The coordinates are h and k. They go in these two locations. So I say, all right, I've got x minus 5. X minus 5. That should look like this. It should look like x minus 8. Now, if I got rid of the x's, I would see that negative 5 equals negative h. I want to know what the actual h is. So I get rid of the negatives, and I realize that h is 5. Or you could just notice x minus and x minus. Those two are the same parts. So the h is just 5. When we look for the y coordinate, I say y minus 3. That should look like y minus k. And lo and behold, it does. Y minus 3, y minus k. That means that our k value is going to be, or let's see, negative k is equal to negative 3. Change the signs, k equals 3. I like to look at it as, if it's a negative h, change the sign, it's positive. So see how here it says negative 5? Change the signs, it's positive. It's a negative 3, change the sign, it's 3. Okay, right here, same process. If I just change the signs, what's the x value? It's negative 2, change the signs, it's going to be a 2. If this is a positive 3, I change the signs, it's going to be a negative 3. And lo and behold, we look at negative 2 equals x minus h. Negative h equals negative 2. Change the signs, gives me 2. Here we have y plus 3 equals y minus k. Get rid of the y's, and we see that negative k is equal to positive 3. Change the signs, negative 3. So no matter what you do, if it's a negative 2 right here, you change the sign. If it's positive 3, change the sign. There's the center of the circle. It's that easy. Over here, we look here and we say it's a positive 9. We change the sign, and we end up with a negative 9. The y portion, notice how there's nothing there. It's just a y squared. Well, it should have looked like that, y minus k. So it's actually looking like y plus or minus 0. So if there's nothing there, hint, nothing, it's just a 0. My coordinate should be 0. Sorry, a little lag, time to catch up. So my center would be change the positive to a negative. If there's nothing there, it's nothing, 0. Negative 9, 0. Here, ooh, fractions. Guess what? We don't have to worry about it. All we have to do is change the sign. If this is negative 1/2, my x coordinate is going to be positive 1/2. If this is 3/4, my answer is going to be negative 3/4. All I have to do is change the sign. Okay, 1/2. Y value is positive 3/4. Well, we have to change the sign to get a negative 3/4. So my final answer is 1/2 and negative 3/4. That should be enough to get you through the homework. Let's see, it looks like problems 1 through 6. All right, if I pull that up in the homework, that's not algebra 1, let's go to geometry. And I find 9.6 homework right here. 1 through 6 it says. Okay, let's talk about it. If I just, it says in the instructions, in the center of a circle, radius. Okay, graph the circle. Geez. Let's find the center. If it's negative 2, we change the sign. So the center is going to be 2. The center is going to be 3. So let's plot that point. Over 2, up 3. Here's my center. Now we haven't talked about this yet, but the radius is going to be the square root of 16. The square root of 16 is going to be 4. So I count right 4, up 4, left 4, down 4, and then I kind of curve it around, creating a circle, That's kind of what we're going to look like for the whole. But I don't see why it says to go to that yet. We'll talk about that in a second. You should just be able to accomplish just finding the center. You don't have to worry about the radius or anything yet, or even graphing it. Just find the center of those 6 problems. That's probably what that means. So if I go on, from previous example, what is the radius of each circle? We're going back through every one. We're looking for just the radius. All right, so now if I look at the equation, I notice that over here it says r squared. So this 4 really equals r squared. So if I square root both sides, I end up with r equaling 2. So again, all we have to do is whatever it equals, square root it. And you'll see that as we go along. 9. Square root of 9 is 3, so the radius is 3. Either way, we set it up to say this is in this location. So 9 really equals r squared. So if we square root both of them, we end up with 3. Like I said, you square root the right-hand side and you're done. So now we look at 144. Again, the square root of 144 is 12, so the radius is 12. The long way to think about it is 144 is in the place of r squared. So we square root both sides, and we end up with r equaling 12. So you can either look at it the long way, the process of this is in this location, or you can think of it as, hey, if it equals it, it should be the square root of it. The square root. Something's broken. Oh, okay, fractions. I know people hate fractions. I'm going to square root the 1/4. Square root of 1/4 is 1/2. You square root the bottom, you break it apart, you get the square root of 1 over the square root of 4, which is square root of 1/2. Okay, now you should be able to find the radiuses of problems 1 through 6. It should go quick. You should just be able to say what's right here, square root it. So in your homework, like I showed you on example 1, we took 16, we square rooted it, got 4. 25, square root. 36, square root. 4, square root. And just fly through and just get the square roots real fast. Okay, now we go on to pi. Pi is irrational. Okay, whenever there's a pi in the formula, pi is in the answer. We never get rid of pi unless we're doing something crazy where we divide pi by pi, but that will never happen for these. You're always going to have pi in the answer. If I ask you for, if you put in 3.14, it's wrong. Leave my pi alone. Just put it in the answer. Don't try and multiply by 3.14. You'll be wrong every time. You'll give me an approximation. I want to know what the exact answer is. So don't use decimals for pi. Just leave it alone. Okay? So right here. Also, pi is never squared. You can't get partial credit if you square pi. So if I ask you for the area, so from the previous 2 examples, what is the area of each circle? Well, r equaled 2. I know my area formula is a equals pi r squared. We're going to use feet for the units. Right here we put in pi r squared. Well, r is 2 feet, so I plug in 2 feet. When I square 2 feet, I end up with 4 feet squared. Now remember, pi is there. It's part of the answer. It's not 4 feet squared. It's not 4 pi squared feet squared. It's just 4 pi feet squared. Do not square pi. Do not forget your units. Okay? Okay. Pi will always be in your answer when I ask you for the area of a circle. For B, the r is 3, and it tells us here to use inches. So I plug in my 3 inches. I square it to get 9 inches squared. But see how the pi keeps coming along? You just leave it there. You don't have to do anything with it. But it will be in your answer. Here we have r equals 12. We're told to use centimeters squared. So I say pi r squared. I plug in my r. I square it and get 144 pi centimeters squared. Again, you don't try and multiply the pi in. You just leave it alone. 144 pi centimeters squared. The last one is r is 1/2. Now we're going to get pi r squared. We square the 1/2 to get 1/4 pi meters squared. Here to use meters for the units, so meters squared. Whenever you're using area, you're going to have a squared value. What's interesting is if you notice this is 1/4. Look what the answer was. 1/4. If I go backwards, you'll see 140. The r is 12, right? But the answer was 144, and this is 144. Whatever's on your equal side is also going to be the area. So see how this says equals 9? 9 pi n squared. Little trick. I'm going to go forward now. Moving forward. All right. So now when it tells us to graph it, oh goodness. All right. We find the center. 3. Plot it. We go up 2, down 2, left 2, right 2, and then we draw our circle. You can use a compass, or you can just sketch it, kind of do your best to hand draw it in there. But make sure you get this down 2, right 2, up 2, left 2 part correct. If it squiggles in the middle here a little bit, it's not that big of a deal. Make it look as close to a circle as you can. Here we plot our point. We found the center was 2 and negative 3. So we go right 2, down 3. I count, the radius is 3, so I count up 3, down 3, left 3, right 3. Okay. And then I sketch the graph of the circle. So now you can graph the circles for problems 1 through 6. Pause the video if you need to. Go through and do them. On the homework, so see right here, we found the center. We found the radius. I put the center here. I went right 3, up 3, left 3, down 3, and I kind of drew my circle. Here, if I change the sign, it's going to be a 1, 1 with a negative. So I change this one to be a 1. I change this one to be a negative 1. So my center is at 1, negative 1, which is right here. My radius is the square root of 25, which is 5. So I count right 5, up 5, left 5, 1, 2, 1, 2, 3, 4, 5, and down 5. And I kind of sketch in my circle. It's a terrible circle, but it makes sense. So that is that portion. Let's see what else we got. Example 9.46, we've got 3 circles. What are the coordinates for the centers? This one's pretty easy. We just have to find the coordinates over and up. So for W, it looks like we go left 4, down 4. So negative 4, negative 4. X, we go up 1. Y, we go right 6, up 5. Once we find the center, we can now find the radius. We go from the center to the edge. We count 1, 2, 3. The radius is 3. The diameter, we can either double that to get 6, or we can count all the way across the circle. And we end up with 6 units. So for X, we count left 4, so the radius is 4. We can double it to get 8, or we can count all the way across the diameter. For Y, we count left 3, so the radius is 3. All the way across is 6, or we just double it, either way. So now if we're going to write the equation of these circles, now I've found the center, and I know my radius. Now we're going to start plugging this information in. So when I plug in this, I get negative 4, negative 4. Well, hey, a minus of a minus is a positive. Now we plug in our radius where it goes, and we have r squared is 9. So my final answer is x plus 4 squared, y plus 4 squared equals 9. There's the equation of the circle W. Now circle X, we have a 0 and a 1. I plug in the 0 for the H and the 1 for the K. Now minusing 0 is kind of silly, so we just get rid of it, and we end up with x squared plus y minus 1 squared. Is we plug in our 4 in for r, we square it, and we get 16. There's the equation of the circle X. This is kind of the same process we just did, but going backwards. Instead of giving me the equation asking you to find this information, I gave you a picture, and then I asked you to find me the equation. We plug in our values. Nothing really changed there. We just subtracted 6 and subtracted 5. We plug in our 3 in for r. We square it to get 9. There's the equation of circle Y. Okay. On the test, you'll be given an equation of a circle in standard form and asked to find the radius, the diameter, the coordinates of the center, the area, and you will graph the circle. So the radius, well, that's just the square root of 9. That's 3. Diameter, we double it to get 6. Coordinates of the center would be 6 and 5. The area, we do pi r squared. The radius was 3, so we do 3 squared is 9 pi squared, or 9 pi feet squared or whatever. Then when you graph it, you find your coordinate of the center, you go over and up, you draw your circle with the correct radius, and you're done. So now you should be able to work on 7 through 12, all of it. To give you an example of what's going on here, if I have a center of 4, negative 5, please fill this in. You're given this information. You know the standard form of the equation. You substitute in the information. You simplify your parentheses. So notice here this is a minus of a minus, so you simplify it. Then you square your radius and you're done. So that should be 13 through 16. And then I think we're done. Summarize what you learned in 9.6. And if you need to rewatch the video, if you have questions, come find me. Be more than happy to help. Let's see if there's any other slides. Oh, yeah, don't forget, on Monday. We're going to do 9.6, 9.7 over a couple of days. And then we'll be done and ready for the test.